Welcome to a new video from ElastiCourse. In this video, we will talk about Docker containers and what is the main differences between virtual machines and Docker containers. We'll also install our first Docker engine and deploy Pi-hole ad blocker on Docker container. Let's get started. First, let's see what is the main difference between a virtual machine and a container. Let's start with the virtual machine. In a virtual machine environment, you have your infrastructure components like CPU, RAM, network, and storage. And then you install on top of your operating system a hypervisor. This is a special software like VMware, VirtualBox, or other hypervisors. And with the hypervisor application, you can virtualize any operating system that is supported by the software. Like this Ubuntu desktop or my Bob OS are both virtual machines hosted using a VMware hypervisor. So every different column in here represent a different operating system where it would contain the guest operating system like Ubuntu in this case. And above the Ubuntu there are certain binaries, libraries, and different applications that you can install in your virtual machine. This virtual machine is separate from your main infrastructure operating system, but it does still share a slice of the resources like the CPU, RAM, and network. Now let's move ahead to the container infrastructure. You still have your main infrastructure component like CPU, RAM, network, and storage. It doesn't have to be as beefy or as big as the resources in a virtual machine model. And then you have your operating system, which can be Windows, Mac, or Linux. Instead of downloading a hypervisor, you use something called container engine. And the container engine can be Docker engine, which is the most famous option. And there are also other providers for containers. But this video we will focus on Docker, and inside Docker, instead of downloading the whole operating system as a guest operating system, you're just downloading the binaries and libraries and applications that you desire in an isolated environment. And because it doesn't have to download the whole operating system, it just download the app with all the dependency that it needs to run. And that causes the system to be super fast and super easy to manage. As we see in a Docker website, they promote their brand as it helps you build and ship apps literally between operating system, because regardless of which operating system you run the Docker engine on, whether it was Windows, any version, Linux, or Mac, with all these variables and all these different hardware combinations, the best option is to use something like Docker engine where your app is guaranteed to work the same experience across all these platforms. Now, Docker website also has the hub. This is a big marketplace with over 3 million apps. You can find any image you can think of in the hub, starting from SQL databases, application for analytics, caching software, full operating system, and many others. I can even search for WordPress and find a WordPress web application ready for use, or Joomla, and I can install it in the same way using a Docker container. Now, one of the best application you can find in the Docker Hub, it's called Pi-hole. This will be our example for this video. And what Pi-hole is, it's a free product that is a DNS level black hole for internet ads and internet trackers. So this app is very popular and it helps you block trackers, ads, and other malicious traffic using a DNS block or a DNS filter. Now, as you see, there are over 100 million downloads for this container already. So this app is very popular and it has a huge community support. In this video, we will download and install Docker engine on Ubuntu platform, and then we will install the Pi-hole container on this Ubuntu Docker environment. In the next video, we will also address how to install Docker engine and the Pi-hole container on the Windows environment. I included all the commands you see in this video in a paste bin where I will put the link in the comments below, so make sure you check this out so you can easily copy and paste these commands for your environment. Now I'm gonna put the terminal and the paste bin side by side so you can easily see what I'm doing. I will start by installing Docker on my Ubuntu desktop 2004. Now all these instructions will work on Ubuntu, but if you are using a different distribution than Ubuntu, or any distribution based on Ubuntu, you can go to the Docker Hub website and you can still find a tutorial on how you can download Docker Engine for your specific operating system. I see in here there is a version for Fedora, for CentOS, Azure, Ubuntu, Debian. So there are a lot of tutorials on how you can download it for different operating system. In my case, I'm also using Bob OS, which is Ubuntu based. So in this case, this will work also on my Bob OS, the same instruction. So I'm going to copy the first line, which removes the older versions of Docker. And since this is a brand new virtual machine, I'm getting unable to locate package because I don't have any older version. Now we're gonna go ahead and do an update command. This update the list for all the Ubuntu repositories. The next step is to download a few packages that can help us download the Docker files in a secure way over HTTPS. Once this is done, we're gonna pull the public key for the Docker repository, and then we're gonna go ahead and add a new repository so we can download the Docker files. This is specific for Ubuntu or any operating system based on Ubuntu. Now the last step is to do an update one more time to fetch the new list and also install the Docker application itself with the other dependency that it needs. Now once this is done, you can verify if the system has been installed correctly by using the command docker -- version. If you successfully installed the version, you should be able to see which Docker version you are using. Now moving to step 2. Newer versions of Ubuntu contain a DNS server by default. It's called DNS Stub Resolver, and it does occupy the DNS service on the Ubuntu distribution. Therefore, we need to do some tweaks so we can disable the service. If we run this command that allows us to see which ports are listening on the Ubuntu or which ports are open for connection, there are two ports listening 631 and there is a port 53 listening. Port 53 is related to DNS, and we can see that the service using this port or occupying this port is called systemd-resolve. In this case, we need to stop this service so that we can use our own DNS service and we can free the port 53 so that it can be used by Byhole. So we're going to use the system control command to stop this service, and we got the name of the service using the listening port page, and it's called systemd-resolve. Now our service has been stopped. We just need to disable it so that it doesn't come up again when we restart our system. Now to verify if we check the listening ports, now we no longer see port 53 being listener. So now we fixed the issue of the port being occupied by the system resolve the service. But now if we try to ping any website, for example yahoo.com, now we lost all our DNS services because of this move. But no problem, this is an easy fix. All we need to do is to modify our DNS resolve configuration file, which is located at etc/resolve.conf. And this file is the one that was hard-coded to use the Ubuntu built-in DNS resolver, and we don't want that anymore. As we remove the service, we need to change the name server from this localhost IP to use some public IP address so we can be able to use the internet again. So we're going to change this temporarily to any public DNS like Quad 8 or Quad 1s. In this case, I'm using Cloudflare. And just once I save my file, and if I try to go up with my arrows and try to ping again, now I'm able to resolve DNS one more time. So now we fix both issues related to DNS. Now we can see how easy it is to deploy a container using a simple shell script. This is available on GitHub website, and it contains simple parameters that help the Docker engine know how to build our container, like which ports are listening and what is the name you want to use. So first we're going to download this file using the wget command. Now this file is on our desktop. We just need to modify a few parameters inside. We also see how it looks inside. So we're going to use the command sudo nano one more time for our text editor. Then we're going to open our docker run shell script. Inside this file, we see the simple command that we need to run any container using Docker engine, which is called docker run. And below that, there is multi-line configuration parameters or argument that is required to let the Docker engine know how to build our container. Inside any container page, you can see these options or parameters under the environment variables. And you can see all the different options you can configure with your container. And then we get the name Pi-hole. Now for the important part, this is called the port mapping. For every port that the container will listen on, there will be two ports or two numbers listed. Now the number on the right will be the listener inside the container itself, and the port on the left will always be the listener on the host machine, like in this case will be my Ubuntu server. So take an example, if you are using Apache already on your Ubuntu server, then your port 80 is already listening and assigned to Apache service. In this case, you can change the number on the left to maybe 8080. And this way, you are freeing up the port 80 to be used by Apache as is, but you're opening a new virtual port 8080 on your Ubuntu. And whenever you hit this port, the Docker engine will redirect you internally to port 80 inside the container. And that's how simple it is to do port mapping. You can use the same port or you can change the port if it's already occupied. Now for the DNS, I don't believe you can change 53, but for the web portal, you can change it from 80 to something else in case the port is occupied. Now for the DNS part, our first DNS server will be the local host, because this will be pointing at the container itself. 127.0.0.1 is a localhost IP, and the secondary IP or the upstream IP we can call it is a quad ones, which is the Cloudflare public DNS server. Now the second important thing to change beside the port mappings if you need it is to change the server IP. Since we need this DNS service to be accessible all over our network, not just inside the machine, we need to give the proper IP address of the machine to the configuration file, which in this case I'm using 172.20.0.24. This will be my static IP address in the server. So I need to make sure I either change the IP address to manual and put this IP address statically to make sure it doesn't change, or you can also do it using your router or your firewall. Whoever is distributing IPs in your network via DHCP, you can create a DHCP reservation to make sure the virtual machine or the operating system always get this IP address. So we're gonna save this IP address in the server IP field, and then we're gonna save our file. Now to be able to execute the shell script, we always have to give permission for execute. And this can be done using the change modification command, and then adding x mean adding the execution permission. We're just gonna give the execution permission to our shell script, and then we can run it under administrative access to make sure we are able to create a container using this shell script, which contains the famous command docker run. So as you see, there is no local image for Pi-hole, so it's gonna download it for the first time from the Docker Hub, which happened very quickly, and then it will start creating our Pi-hole container. And in a few seconds, the container was created and I was given an auto-generated password to log into the GUI. And this is part of why Docker containers are getting so popular lately, because they are super fast and easy to create. There is no virtual machine could ever be created and finished from A to Z with the service running in this short period of time. Now that our container is running, we can try to access the GUI using either the localhost IP, which is 127.0.0.1, or we can also use the private IP 172.20.0.24. And once we go inside, we can go to the admin page, and this will be our guest view. We can see that there are over 84,000 domains that are blocked on this block list. And once we start connecting from our clients to this DNS server, we're gonna start seeing the queries and the block numbers are increasing. But since we have no clients pointing at the system yet, everything is showing 0. Now we can log into the system using the automatically generated password we got over in a terminal. And once we go inside, we start getting more detailed logs and more detailed metrics, like which type of queries are getting to the DNS server, what kind of response are they getting, what is the most used or frequently used domains, and which guys are sending the most DNS queries. There are also a detailed logs with every query that got pointed to the system. As you see right now, everything is saying localhost because all of these are just the internal application queries and nothing from our clients yet. Now, to be able to start pointing our clients to use our Pi-hole as their DNS service, we can start by our Ubuntu itself. So we can open our resolve.conf one more time, and this time we're going to change it back from our public IP for Cloudflare, and we're going to point it at ourself, which is 172.20.0.24. This way we are forcing our own system to be using Pi-hole as the DNS service. Now that the file is saved, we can start visiting any website, and we can start already seeing that some banners and some advertisement in different websites are not able to go through due to DNS resolve issues. But you can still see some ads still go through because not all the domains are blocked and the app is not 100% proof against all kind of ads. It does help a lot with trackers and hidden scripts that are running on a lot of websites, and we're going to also see how we can expand that a little bit more. Now, after less than 1 hour, I'm getting over 400 queries blocked, and the percent of the block at this point is really high, 51.6%. Now we can see that this block list is occupying over 50% of the traffic I opened in this 1 hour. And even though we were not able to block all the commercials, we still blocking hundreds of ads and trackers from our base configuration. Now under the query log, we can see the latest 100 queries. Now we can start seeing the status for all these client requests, like is it gone through or is it blocked, and you can reverse the operation or override it if you need to. And we also have a top list, which is a nice graph which shows us what are the top domains and what are the top block domains for a specific period of time. It shows you how many hits and what is the frequency that this kind of event happen. And also the top domains is for the permitted domains. We can also see what are the most permitted domains that have been visited and what are the top clients sending DNS requests. Now, mostly right now is coming from the system itself because we haven't pointed the rest of our clients to use this new DNS server. So now I can move to my firewall because this is how I run my DHCP, but you can replicate the same settings in your router and change your DHCP server to send the IP address of your Pi-hole to your clients as a DNS server. So I'm going to start with my internal tool, which is running my first DHCP server. I can see in here the DNS server is pointing at a different IP address. So I need to change that whole setting and point it now to my Pi-hole IP address 172.20.0.24. And now every time somebody behind my internal tool network will get a DHCP lease with this Pi-hole IP as the DNS service. We're gonna OK to that. Now to verify that the internal tool or the BC network has been updated properly, if we do the ipconfig/all command, we can see in here the DNS server is still the old DNS servers that were defined before. That's because we got a lease already that will not expire before July 14. We want to force the computer to release and get a new DHCP address. We can do so using the ipconfig/release. Following that, the ipconfig/renew. Those two commands will always make sure your computer gets a new DHCP lease with the latest information. So now if we do the ipconfig/all one more time, now we are officially on the new DHCP lease. We're getting the updated DNS server, which is the Pi-hole. So now our Windows 10 client is also using the DNS service running from Pi-hole. We can point it to the main screen so we can see the numbers dynamically updating. We're going to use the famous command nslookup, which is a Windows feature that allows you to run DNS queries right from your command line. Right now we can see it's already recognizing the Pi-hole as the DNS server. Now if we run any query, we can see the number dynamically go up and we are getting a proper response. So now we verify that our Windows 10 have no issue communicating back and forth with our DNS server Pi-hole running inside the container inside our Ubuntu. And you can notice even with 84,000 domains in the block list, the system goes around this list super fast. You don't feel any lag or any issue getting fast response. Now we can do the same with our two other interfaces on the firewall. So how many DHCP servers you use, you have to redo the DNS server setting on every one. And once you do this, if you need to renew your lease or rejoin the network to make sure you are getting the updated DNS server, and then all your clients are connected to your Pi-hole. Now you have to make sure to not turn off the machine running the container or the virtual machine, because this way you will block all the DNS queries and then all your clients will lose access to the internet. Now to make sure our service run with no interruption, we need to make sure that this IP address assigned to our Pi-hole container 172.20.0.24 has to be statically assigned to this machine. So we're going to see how we can do it using the Fortigate, using the DHCP option. So we're going to add a DHCP monitor dashboard. This is something new in 6.4 version where you have to add the monitor pages on the dashboard. And then we will see our DHCP log. We can see our Ubuntu got the DHCP release 172.20.0.24. We want to make sure that the Ubuntu always get this IP address so we don't break our DNS. So we can either do it using the setting menu in the Ubuntu, or we can simply create a reservation using the Fortigate. And every time this MAC address sends a DHCP discover, it will always get this offer for 172.20.0.24. Can also give it a name by hole to just recognize it. And now we have our DHCP reservation that takes care of the issue of not having a static IP address. Now comparing this number with the server I have been running just for 2 days, you can see the number of blocks is going dramatically high, and also the percent block is also more reasonable, and that's how much blocks you can get just running it a short period of time. It will help you block a lot of the junk that you don't see or you can block with other ad blockers. And with the addition of something like AdBlock Plus, which is a Firefox and Chrome extension, you can block most of the ads without doing much work. Now we're going to also check our group management, and inside group management there is an ad list. Inside the ad list there is a default 4 big list of domains that are blocked using Pi-hole. This is the 84,000 domains are listed in those 4 files. You can see the simple structure of the file. It just contains all these unwanted domains that are related to malicious traffic, ads, trackers. It will just redirect them to either 4 zeros or the localhost 127.0.0.1. And any domain that is assigned 4 zeros or localhost IP, it will never make it to the final destination. It will never work. And that's how the app blocks these DNS queries, by assigning them wrong IP addresses. You can also expand beyond these 4 files. For example, there is a website called Firebug, which contains big text file related to tracking malware, malicious websites, and other very useful lists. If you open these files, they are structured in the same way. They are just assigning bad domains to localhost or 4 zeros to make it not work, which is great. And the app can also go through all these additional lists in the same way it does with the 84,000 plus that it looks for by default. So I'm going to try to add this anti-malware list. And now I have one additional list to the default ones. Now we can also go back and try to get something related to advertising or marketing. We're going to copy this list as well. And we're going to go back to our Pi-hole and add it to our group management. Now we have 6 different lists to look for. Now the number on the dashboard did not change yet because we need to go back and update our gravity list. Once we do this, number will reflect on the dashboard. We can see in here that we added 125 extra sites to our block list using the 2 additional lists. Now under the setting, we can see simple system information about our server. And under DNS, there is the upstream DNS server. We choose in this case Cloudflare, but you can define which public DNS server you want to send your queries to. Because Pi-hole is not a DNS server by itself. it redirects all the requests to the public DNS after it goes through all these adlist filters and other filters you set up on the application. You can change Cloudflare to Google if you prefer to, and you can choose the primary and the secondary server for each provider. You can also enable IPv6 if you are configured for IPv6. And once you save, the new DNS server you choose will be the active one. Now, also an important command is the conditional forwarding, which allow you to resolve internal domains that are not publicly accessible, because Google or Cloudflare will not be able to resolve this kind of domain. You can simply define your internal domain. For example, elasticourse.local is mine, and then I can define which DNS server or which internal system that knows how to resolve this kind of domain. For example, I want to say my DNS server lives at 10.200.150.150. This will be my DNS server for my internal domain, and this way I'm doing conditional forwarding just for this domain to my internal DNS server. Anything else will just be sent to the public DNS server, whether it's Cloudflare or Google or anything else. Now, to be able to see which containers are running in your environment, you simply do the command sudo docker ps. You can see in here what is the name of the container, how long has it been running for. You can see it says healthy, so everything is running good. And then you see the port mapping that we configured when we started our container, where we see our port 53 for the DNS queries, port 80 and 443 for management, and also port 67, which is DHCP in case you are using Firewall also for DHCP, which we are not. And that's how easy it is to install Docker Engine and install Pi-hole container on Ubuntu. Thank you for watching.